Hi, my name's Dan Coakwell, and I'm in Section 1 of Fundamentals of Physics. Today, I'll be demonstrating the effect of mass on inertia. To do that, I have this bottom half of a 2-liter bottle. Now this bottle is going to represent our mass. Mass is known as how much matter an object contains. We can see that this object contains little matter, therefore has little mass. We also have a rubber band attached to a string. Now this isn't any normal rubber band attached to a string. This rubber band is going to help us observe Newton's first law of motion, which states that an object in motion tends to stay in motion, or an object in rest tends to stay at rest unless acted upon by an outside non-zero force. So, this rubber band is going to help us measure inertia. The more the rubber band stretches, the more inertia. The less the rubber band stretches, the less inertia. So for our first experiment, we're just going to run this as is and see how much inertia this object of little mass has. So we begin to pull on the string and we see that the bottle moves without the rubber band stretching. So we see that this object has very little inertia. It requires very little force to get it moving from its state of rest. But let's see what happens when we add a significant amount of mass. Now this time, when we begin to pull the string, we see that the rubber band begins to stretch. Now what this tells us is that it actually has inertia. This object is resisting change, and it's resisting its change in motion, which we're seeing by this rubber band. Now we see that this object has significantly more inertia than our object of small mass. And when we begin to pull it, it moves. So, in recap of today's podcast, we use Newton's first law of motion to show that an object of small mass has small inertia and an object of larger mass has larger inertia.